Hello. In the question 12, we're going to do some practice PCA on paper. Alright, so for the covariance matrix for PCA, we're going to need to first look at our data. So we have, here's our data, x. We have a first dimension, x1, and our second dimension, x2. Now for PCA, when we're calculating the covariance matrix, we can calculate it one at a time, but we really don't recommend doing that. So we're going to use a formula, 1 over n, where n is the number of dimensions, times x hat transpose x hat. Now remember, x hat is just the mean subtracted matrix of our data. So what that means is for every column of x, we're going to subtract the mean of that column. So what we're going to get is x1 minus x1 bar, x2 minus x2 bar. And that's going to be x hat. So we can see that, where do I put this? So here's our formula. x1 bar equals 0.5, x2 bar equals 2, because that's 4 over 2, and this is 1 over 2. Alright, so then x hat equals 0.5, yeah, not negative there, 0.5, and then negative 1, 1. Alright, now we're going to perform our math, so we have to do 1/2 times 0.5, negative 1, 0.5, 1, because this is x hat transpose. Then I'll do the normal matrix up here. Yep, okay, and then this should give us 0.5. That is 1, 1, and this is 2. So we get 0.25, 0.5, 0.5, and 1. This is our PCA matrix. You're welcome to do it one entry at a time, but generally this is going to be much faster. Alright, for part 2, we're going to find the variance of the first dimension of the data. This is pretty simple. Same formula as last time. 1 over n times, d x sub I minus x bar squared. That's our variance formula. So we'll just do this. So it's 1 over n times negative 0.5 times negative 0.5, or no, no, this is for each sample of the data, so I'm going to do, yes, it is 0 minus 0.5 squared plus 1 minus 0.5 squared, and n equals 2 because we have 2 data points, so we get 1/2 times 0.25 plus 0.25, which equals 0.25. That is our variance for x. And our variance, I believe, part 3 asks for the covariance between first and second dimensions of the data. So that is going to be, I believe, the same formula. So 1 over n, the slight difference, which is x sub I minus x bar, y sub I minus y bar. And that we do, I believe, 0 minus 1/2. I'll switch to fractions here because I'm tired of writing decimals. Times 1 minus 2 plus, yup, 1 minus 1/2 times 3 minus 2 over 2, which equals, what is this? Negative 0.5. So this is negative 1/2 times negative 1, so that's just 1/2 plus, this is 1/2, and this is 1, so that's also just 1/2 for 2, which equals 1/2. So covariance is 2, or sorry, not 2, 1/2. All right, this is the problem.